lesson 8.4, factors affecting solubility. So there's a couple different things that we can do to increase the solubility of a substance. The first thing is agitation. Agitation involves stirring or shaking the mixture. This increases the number of collisions between the solute and the solvent particles. So think about if you want your sugar to dissolve in like the sugar from the Kool-Aid flavoring packet, you stir it to increase the rate at which it dissolves. Surface area, breaking the solute into smaller pieces, there's going to be greater surface area, and this allows more collisions to occur. If you think about a sugar cube, you only have 4 surfaces to collide with. But if you have the individual sugar granules, there is much more surfaces for the collisions to take place. And that's what breaking it into smaller pieces does. Temperature, solubility of solids dissolve faster in a hotter solvent. So if you want that sugar to dissolve and make sweet tea, you're going to want to have a warm cup of tea to start with versus a cold cup of tea. Solubility of gases, they're going to dissolve faster in a colder solvent. So the CO2 in your can of soda is going to be more dissolved when it's refrigerated than when it is at room temperature. Solubility is the amount of solute that dissolves in a given amount of solvent. So we're going to talk about 3 different types of solutions today. The first 2 are saturated and unsaturated solutions. So here we have our solvent in the blue, and the purple dots are the solutes. So you can see in the saturated, there's many more particles of solute than there is in the unsaturated. So a saturated solution is a solution that contains the max amount of solute. So you can't dissolve any more in this solution. The unsaturated is a solution that contains less than the max amount of solute. So we can still add solute to this solution. Solubility of solids. The solubility of most solids increases as the temperature increases. Now notice I said most. Here's a graph, and it shows the solubility in grams of our different solutes, and then our temperature is increasing here on the bottom. So all of these tend to be increasing except for the cesium sulfate, and that one is decreasing as the temperature increases. So we're going to take a little look at this graph and interpret what this graph is telling us. So for potassium nitrate, here is potassium nitrate. We want to know what is the solubility at 20 degrees Celsius. So we're going to look here at 20 degrees Celsius, and we're going to follow it until it hits the solubility curve for potassium nitrate. So the solubility of potassium nitrate at 20 degrees Celsius is 30 grams of potassium nitrate in 100 grams of water. So the amount of solvent is very important, because if I decrease from 100 grams to 50 grams of water, I'm not going to be able to have 30 grams of potassium nitrate dissolved at 20 degrees Celsius. If I increase this to 200 grams, I'm going to be able to dissolve more. So what happens to the solubility as temperature increases? Well, as temperature increases, the solubility for potassium nitrate is also increasing. If you dissolve 50 grams of potassium nitrate in 100 grams of water at 40 degrees Celsius. So here's 50 grams, and then here's 40 degrees Celsius. So put a point where those two marks meet. We want to determine, is the solution saturated or unsaturated? So that point is below the solubility curve for potassium nitrate. So I can still dissolve more. So this solution is going to be unsaturated. Okay. So now let's take a look at potassium chloride. So here is the potassium chloride solubility curve, and we're asked, if you dissolve 50 grams of potassium chloride in 100 grams of water at 40 degrees Celsius, we want to know, is the solution going to be saturated or unsaturated? Well, this point is above the line for potassium chloride. Back here, the point was below the line. So this is the general rule of thumb. If the point is under the line, it is going to be unsaturated. If it is above the line, or if it is on the line, these are both going to be saturated. Now, if it is above the line, we have dissolved the max amount of solute, but we have some solute that is undissolved sitting on the bottom of the container. So now when we take a look here, this point is above the potassium chloride line, so this is going to be a saturated solution. So we have dissolved the max amount, which is about 38 grams of potassium chloride. So we have about 12 grams of potassium chloride that is undissolved. So what temperature would we need the water to be at to dissolve all 50 grams of that? So we're just going to follow this over till the line hits the solubility curve, which is at about 75 degrees Celsius. Okay. So you will have the chance to interpret the data for more of these chemicals later on. A supersaturated solution, that's the third type of solution that we're going to talk about. A supersaturated solution contains more dissolved solute than the saturated solution. So how do we make a supersaturated solution if we already have the max amount of solute that can be dissolved? Well, you're going to start with a saturated solution, and then you're going to heat that saturated solution to a higher temperature, because higher temperature increases solubility. And then you're going to add more solute to the saturated, or you're going to dissolve the excess that has not dissolved. And then after all of it is dissolved, you're going to cool it slowly to allow the excess solute to remain dissolved. So a supersaturated solution is going to be characterized by heating it and then slowly cooling it. Now, if we didn't slowly cool it, we would have a precipitate that would form. So this part about cooling it slowly is very important. So here is the solubility of gases. Those curves are all going down. So the solubility of gases decreases as the temperature increases. And the other thing that affects the solubility of gases is the pressure. So as pressure increases, solubility is going to increase. So let's apply this to a can of soda. So here's our can of soda. It's sealed, so it's under pressure. The CO2 is dissolved into solution because you just took it out of the fridge, so it's at a colder temperature. Now your can of soda is out of the fridge, so you're going to open it to take a drink. So when you open it, you are going to decrease the pressure, which is going to decrease the solubility of the CO2. And then as it sits out on the table, the temperature is going to increase because it's not in the fridge any longer. And so as the temperature increases, the solubility of CO2 is also going to decrease. So this is why if you open a can of soda and you leave it out at room temperature, it's going to go flat because that CO2 is all going to be released into the atmosphere, and that CO2 is what keeps your soda from going flat. Okay, you have practice problems on the bottom of page 8 and the top of page 9. If you missed class, you need to stop by and see me because there was also an additional practice worksheet to go through. So if you have any questions, stop by and see me. Thanks for having a great day.